Hello, this is Mr. Brooks, and welcome to Lesson 2-3, Deductive Reasoning. In this lesson, not only will we learn what deductive reasoning is, we'll also learn something called the law of detachment and a law of syllogism. First, deductive reasoning. Deductive reasoning is the process of reasoning logically from a given statement to a conclusion. If your given statements are true, deductive reasoning always produces a true conclusion. Unlike inductive reasoning, if you remember inductive reasoning, we looked at a pattern, tried to figure out what comes next. Sometimes that gave you a true conclusion, sometimes it did not. Deductive reasoning will always give you a true conclusion if you reason logically. For example, if we look at example 1, an auto mechanic knows that if the car has a dead battery, the car will not start. The mechanic begins work on the car and finds the battery is dead. What conclusion can she make? Hopefully you will agree the mechanic can conclude that the car will not start. Now let's look at quick check number 1. Suppose the mechanic begins work on the car and finds that the car will not start. Can the mechanic conclude that the car has a dead battery? Please pause the video while you explain. Hopefully you will agree that that would not be a correct conclusion because there are many other reasons that the car might not start besides that it had a dead battery. Now let's look at the law of detachment. The law of detachment states if a conditional is true and the hypothesis is true, then the conclusion must be true. In symbolic form we would say if P then Q is true statement and P is true, then Q has to be true. Now let's look at quick check number 2. Let's use the law of detachment to see if we can make the correct conclusion. If a baseball player is a pitcher, then the player should not pitch a complete game 2 days in a row. Vladimir Nunez is a pitcher. On Monday, he pitches a complete game. What can you conclude? Hopefully your conclusion was that Vladimir Nunez should not pitch a complete game on Tuesday. The next and final property we need to learn in lesson 2-3 is called the law of syllogism, which states if you have a statement that says if A then B, and that statement's true, and you have another statement that says if B then C, and that's also true, then the statement that says if A then C, that must also be true as well. Now let's look at example 4 to help you better understand the law of syllogism. Alright, let's say we have the statement, if a number is prime, then it does not have repeated factors. And that's true. And if we have the statement, if a number does not have repeated factors, then it's not a perfect square, also to be true. Then, since both of these conditionals are true, then, and the conclusion of the first conditional is the hypothesis of the second conditional, then we can make the conclusion that if a number is prime, then it is not a perfect square. Now let's look at quick check number 4 to see if we can figure out a conclusion from the law using the law of syllogism. If it's not possible, let's see if we can explain why. Alright, part A says, if a number ends in 0, then it's divisible by 10. True. If a number is divisible by 10, then it's divisible by 5. Also true. Tell me, using the law of syllogism, a conclusion you can make from this. Please pause the video while you try to figure this out. Again, the conclusion of the first conditional was the same as the hypothesis of the second conditional. So, we can put these together using the law of syllogism and say, if a number ends in 0, then it's divisible by 5. Now let's look at quick check number 4, part B. First conditional, if a number ends in 6, then it's divisible by 2. True. Second conditional, if a number ends in 4, then it's divisible by 2. Also true. Can you use the the law of syllogism to come up with a conclusion from this, or are you unable to? If so, explain. Please pause the video while you try to figure this out. Hopefully here you see that you cannot use the law of syllogism on this one, because the conclusion of the first conditional is not the same as the hypothesis of the second conditional. Since these two do not match, you cannot use the law of syllogism. Now let's try to put both the law of detachment and the law of syllogism together to try to make a correct conclusion from the following statements in example 5. If a river is more than 4,000 miles long, then it is longer than the Amazon. If a river is longer than the Amazon, then it's the longest river in the world. The Nile is 4,132 miles long. Try to come up with a conclusion from these three statements. First, we would use the law of syllogism to, in the first two statements, to put together, if a river is more than 4,000 miles long, then it's the longest river in the world. Then we will use that statement and the fact that the Nile is 4,132 miles long to put those two together using the law of detachment to come up with the Nile is the longest river in the world. For your quiz tomorrow, I want you to try to do quick check number 5 on a piece of paper. I want you to try to apply the law of detachment and the law of syllogism to try to make a conclusion from the following three statements. The Volga River is in Europe. If a river is less than 2,300 miles long, it is not one of the world's 10 longest rivers. If a river is in Europe, then it is less than 2,300 miles long. Please try to make at least one conclusion. Hopefully you can come up with 2 conclusions from those statements and be ready to turn them in tomorrow.